So in our local repository, our master branch is ahead of origin/master by one commit. So we can use the push command to send this new commit to origin. When we run this command, Git will send our new commit to the remote repository. Then it will move the master pointer forward to point to C. And finally, it would move origin/master to point to C as well. So we type git push. Next, we specified the remote repository, in this case, origin. And finally, we specified the branch we want to push, master. Now, currently we are on the master branch, so we can drop master. Also, if we drop origin, Git will assume origin by default. So we just type git push. Here we have to enter our GitHub credentials. So I'm going to add my email and password. Good. So Git sent our new commit to origin. Let's verify it real quick. So here on GitHub, look, we have 4 commits, and here's the last commit that we just pushed, add file1. Now, sometimes your push may get rejected. Let's see why. So once again, our local repository is ahead of origin by one commit. Now, let's say before we do a push, someone else does a push and adds a new commit to origin. Now, if we do a push, our push will get rejected because our histories have evolved differently. So Git prevents us from overwriting someone else's work. Now, I've seen some people using the force option here. This is a terrible thing you can do. With this, you're telling Git to drop other people's work and replace it with your work. This is not what we want. So unless you have a very strong reason for using the force option, you should never, ever, ever, ever use this option. Basically, you should use this only if you have screwed things up. So what can we do here? Well, we have to do a pull to bring other people's work into our local repository. Then we have to do a merge or a rebase. If there are any conflicts, we have to resolve them, and then we can do a push. Now here's a question for you. Look at the history of these 2 repositories. What commits do we have in our local repository that don't exist in origin? C and M, right? Because in both these repositories, we have A, B, and D. So when we do a push, Git will send these 2 commits to origin. Now we have the same state in both these repositories. The final code and the history of changes are identical.